Hi, my name is Alvy Chen. I'm going to do a presentation on Los Angeles crime data analysis, and this is a project for my CS5993 Introduction to Data Mining class in the University of Oklahoma for 2017. And this is the outline of my presentation. So I'm going to give a short introduction, talk about the related works, and the rest of the presentation I'm going to show the web application I create and the prediction model, do a demo, and wrap it up with the conclusion. Okay, why do I choose this project? And I live in Los Angeles. It's interesting to do a client analysis in the city. So the objective of the project is to predict the number of clients that will occur in the future in a location. For example, I want to predict the number of clients that is in within 5 mile radius of Staples Center, and from December 1st, 2017 to December 31st, 2017. So, data client prediction is a challenge task. There's a lot of related works that have been done. There's prediction using time series and prediction using client type, using spatial and temporal data. And there's also forecasting client rates with a Gaussian model. Client prediction is still remain a pretty challenging task because there's just so many factors that can affect the accuracy of your model. People moving in and out of city, the policy change, all those factors can affect your model. So here is the overall architecture of my web application. So it's a web application. The user will enter the input and select the action on a web interface. The web application is deployed on a Tomcat web server. So you will get the user request from the user input, and the web application will pretty much create a all request and pass it to the all server. And the all server is another process that's running on the system. Is responsible to executing all the all command, and it basically is the one who's doing all the data analysis works, and it will pass the result back to the web app, and the web app will pretty much forward it to the user interface. So in here, the web application is simply a pass-through, so it communicates with the all server using a Java package called the all engine. So it's an open source package and is available on the web. So next is the dataset. The dataset I use is from Los Angeles city.org, and it has about 1.6 million client incidents and 26 variables. And first, I did some data processing. I only used select the attribute that is relevant for my analysis. So those are mainly the spatial and temporal attributes, and also that the client type and area. So I also removed the missing and invalid data. So I think after the removal, I end up with about 1.52 million client instances, and which is sufficient for my analysis. Okay, from now on, I'm going to do the presentation and the demo at the same time. So, and the first step in the data analysis is what I call the data understanding and data visualization. So I'm going to show the feature I created for to visualize the data. So here you see is the my web application. So you will first compile it and you do a Maven build and you compile. Okay, it's done. And next you want to simply pretty much want to deploy on the on a target location. Okay, it's done. And after that, you can pretty much start the web server from command line. So here, I simply going to open another window, just in case there's some cache on my browser. That okay. So here you see that I have those are the actions, the feature available in my web app. So you have search data type and search client area, search client location, search client trend, and search find the client hotspots, and so on. So and I'm going to show each one of them. Right. So and here you enter the location Stable Center, Los Angeles, and between 5 mile radius. And the from day is, for example, January 1st, 2016 to May 1st, 2016. And the client type, I'm going to leave it empty. So you have to enter NA if you don't care about that that field, because all input are required. So, and then I'm going to do a search. And you basically you will see that is is talking to the R server, which is I started already on in RStudio. So here I'm going to go back to my presentation and to talk about what are we trying to accomplish from data visualization. So we want to understand the past crime data, right? So you want to know which crime has the most number of incidents and what is the trend of the crime now? Is it increasing, decreasing, or the same? And which area in the city has the most crime, number of crime? So and this one is we're going to use those data to determine what attribute and feature we're going to use in the prediction model. And also that those are some useful feature for anyone who want to learn about the past history of crime history in the city. So that's why what data visualization is for. Okay, you go back there. And by the way, yeah, this one just takes some time, and this is the longest query I have. The other one is pretty quick usually. So that's why I do the present demo and presentation at the same time. So you should come back up really quick. Let me see what's the status in our studio. Yeah, all the query has been completed. So okay, it's done. It's come back up right here. So as you can see, and that's those are the client type, sorted in decreasing order. So you see that battery, it has the most count and so on. So and the next one I want to show is the search client area. So here I want to search the entire city and to see which area has the most crime number. Okay, so this should be a really quick query. So yes. Okay, so here you see that 77th Street is has the most incident count, and the next one is Southwest, um, and so on. Okay, the next one. The application actually has a some I think is pretty cool feature. It allow you to search um, incidents on the map. So it will put each incident on the map. So and here's the same. Um, okay, and let's restrict the crime type to robbery, and this time. Okay, so you search location. Right. Okay, so here you see that those are the each red dot is represent one instance. So stable centers right here, and you see that this is 5 mile radius, and those are all the robbery that occurred in the city from January to May 2016. So the next one, I just want to look at what um, the crime trend in the city overall. Right? So I want to look at from day one, 2017, to, for example, first no, 2010. That means uh, 2017. So the crime type is robbery. Okay. All right. So I'm gonna do a search. Okay, here you go. That's what you see. So you see that, okay, this one is misleading because it hit the boundary. So and you see that the crime was like high at the beginning and that kind of decreasing, and eventually that's kind of increasing as it go toward 2017. Okay. All right, next, the other thing I did is that I have something called the hotspot analysis. So I used the a priori association analysis. That's to find what the hotspots in the city. Hotspot, is defined by a, a, a time and location where the crime happen frequently. So here you see that in from the park, right? You see that the area 77th Street Saturday, and the time from 20 to 24, which means 8 p.m. to 12 a.m. at night, has the its most frequent um, hotspot. And the next one is Friday, also from 8 p.m. to 12 a.m. So, and those is my expectation. I expect those area to be has a is a crime hotspot. So, and the next one I did is what we call the association rule analysis. So, as you recall, right, we want to find the relationship between um, robbery and the area and the day and the time interval. So and and here you see that for robbery is highly related to area rampart, and the day is Saturday, and the time is from 8 p.m. I mean 12 a.m. to 4 a.m. in the morning. So the next one is Olympics, and also the day is also Saturday, and the time interval is also 12 a.m. to 4 a.m. in the morning. So again, and those are is what I expect too. So I expect since actually when Paul and Olympic are neighboring city, so I expect they are they are highly related. So okay, so the next one I'm going to talk about um, the prediction model. So before I do that, I want to go back to my application. I want to kick off the prediction uh, search first. So the same. I want to search for Los Angeles, California, radius 5, and so I want to search predict the climb for August 1st, 2017 to September 1st, 2017. And I want to limit the client type to robbery again. Okay, so why August 1st, 2017? And I do that so that I can compare with the actual data. And that will be what we call the test data. And so I can do a evaluation on how good this prediction model is. So I'm going to kick it off now. All right, so go back to the presentation. Okay, so as you know, the data set has doesn't have anything like tell you what is the climb count, for a particular day, week, or month. So it doesn't tell you that. It just have a whole bunch of incidents. That means that we need to create a data set that we can use to train our model. So, and the first thing we need to do is called the feature engineering. So, and the first thing I did is that I aggregate all the kind happen on each day. So, for instance, for here I have this 31 count happen on January 1st, 2010. So, and I also that create the feature, so that is going to be for the prediction model. So those are what I see as the important feature. It has the month of the client, and the day is just like Monday to Sunday, and the date of month, so it's day 01 all the way to day 31st, and what is the season, of that day. So, and what's the average client, in the in the entire data set. And here I also created something called a trend, which is using the linear regression. So as you can see, that if you look at the entire trend from day 1 to today, it's almost close to 0, and the trend increased since last week and decreased last month, and from compared to last year, it's also about the same. So okay, and this is going to be our training data set, and I built the prediction model using linear regression. So linear regression, and the good thing about it is easier for you to try different type of formula. So it's usually work really well when you want to predict a numeric value that has a high variation, So okay, let's go back to the query, right here is done, right? So you will see that it predict the number of clients for August 1st, 2017, all the way to September 1st, 2017. From if you want to know the total number of coins, you just sum all those things up, right? So that's all. And going back to the presentation. Okay, so and that is the prediction we create. We have. So how is that? How is the how well is the model perform, and how is so here we evaluate the model using like a few data, right? Data point. Um, so we compare the prediction versus actual, and the other statistic we're going to look at is the RMSE, MAE, and R square. So the model evaluation, right? So here you'll see that I plot prediction versus actual coin count. The blue line is the actual one. The red line is the prediction. So as you can see, right, my model is kind of it predict the value in the median, right? So it does not. Let's say there's a day there's a hike in the client count, so my model just does not pick it up. And so and here the the blue line is the actual one. The red line is the prediction one. The predict with is the prediction. So if you look at the RMSE, it's come out to be about 4.5. So is it 4.5 a good number? Is an acceptable number? Well, if you look at the data here, right, this data set has high variation. So it range from the lowest is about 6 and the high is about 27, right? So I would say that all the RMSE is 4.5 is acceptable, even though is the smaller is the better, right? Is of course. So also you look at the R square is come out to be about 0.01, and which is the R square explain how much variance our prediction model has, So, and it's almost close to zero. That means it does not explain anywhere like the variant in the original data set. So that's why you see the prediction is almost like always in the like around the average, of the the client count in that month. So and so how good is my model like compared to, for example, if you're just going to average the count, the client count, for the month of August last year. So if you do the average, there is it's come out to be for last year. Last year it's gonna be 11.3, and the prediction of my model is 11.6. So my model perform slightly better than if you just pick use an average number from the same month last year. All right. Okay, so demo, right? I already did the demo as I go through the presentation. So just to show again, and this is the my web interface. So the only thing I didn't show is that you can also use to find the hotspot, the association rule, and the association rules graph. All right. So okay, what about in the presentation with the future works? Okay, my prediction model is all right. It's just average, I will say. So it does not pick up the variation, from the original data point that well. So, and I think one of the reasons being that I use all data point, all data from all the way from 2010 to 2017. And maybe I shouldn't be doing that because when you use like a huge number of like data for your model, you usually just pretty much like overfitting it, underfitting it. So and I might want to just like choose a some month, like they some like select a particular time periods for my model instead. And another thing is that I will consider to use is that so right now, let's say I want to find the crime, predict the crime in around Stable Center, Los Angeles. So I only going to use the same data point, data set, data from to train my model, and maybe I should be using data from the neighboring area as well. So because those apparently they affect the the prediction, the crime number. Okay, so and another thing I want to just pretty much compare the linear regression model with for example, a decision tree or extreme boost tree model. So and for the web app, so I need to improve the web user interface performance. Which is like sometimes it take a long time to do a search. Because this is a large data set. So I also plan to host the project on a server and write code automatically to update the data set. Um, okay, and that conclude my presentation. And I hope you enjoy it. And thank you.